Meta AI is now using Llama 4, which was released in April 2025. The model is open source and capable of generating images and animations. My name is Mehrdad Arashpour, and today we'll review Llama's animations with a comparison to Sora and Veo 3. We use a research case of project safety analysis to generate several animations, including the use of metal grinders, manual lifting of heavy loads, electric hazards, painting safety risks, unguarded openings, and trench-related incidents. These animations can be used to train deep learning models for action recognition or object tracking to identify leading and lagging indicators of project safety. There are other alternatives for video generation, such as OpenAI's Sora and Veo 3 by Gemini. For example, to have fast and high-resolution generations in Sora, you need a ChatGPT Pro plan for an eye-watering cost of $200 per month. The maximum video resolution, however, is 1080p with a duration of 20 seconds. Let's head over to meta.ai, which is completely free to use, and together we'll evaluate Llama 4 to generate images and also animations. Its interface is very user-friendly, and the Imagine option is used for text-to-image generations. Let's test this model to generate our first artwork using the prompt, a photorealistic image of a tradesperson who is cutting metal with an angle grinder. As you can see, with the single prompt, 4 photos are generated, which have a reasonable quality. You can change the aspect ratio of images to be 1:1, 9:16, or 16:9. You may select a suitable image and refine it. For example, on this image, I wanted to remove the goggles to highlight the risks of not wearing personal protective equipment or PPE. When we are happy with the quality of the static image, we can use the Animate button to generate a 4-second clip. The results are fascinating. You can see the movement of the worker and the grinder with the sparks going everywhere. This is not a simple use of panning or zooming, which is often used in competitor platforms. The animation is detailed and can be used to train action recognition algorithms, such as multimodal VIT or MMViT, and also convolutional neural networks or CNNs that can analyze the spatial and temporal features within the video. Let's move on to our second safety research scenario and provide this prompt. A hyper-realistic photo of 2 laborers lifting a heavy structural timber without coordination or using mechanical aids, which result in straining and losing balance. In our video, we want to focus on ergonomic lifting to minimize the risk of injuries. So let's use prompt engineering and generate better results. The new prompt to model is 2 laborers lift a heavy structural timber horizontally without coordination or using mechanical aids, which result in straining their backs. The ergonomic hazard is obvious. Now results are better suited to our video analysis for safety, and we can select the proper image to animate it. By clicking on the Animate button, we can generate a 4-second animation of our static image. The body position suggests potential strain or lack of synchronized effort, which is a leading indicator of unsafe lifting practices. Attention mechanisms in transformers and CNNs will also focus on the heavy machinery and other workers in the background, which are indicators of potential hazards like uneven terrain or equipment proximity. By the way, only around 46% of our channel regular viewers are subscribed. If you are enjoying our content, please give it a thumbs up and consider subscribing. Thank you. At this stage, we want to animate electric hazards in projects. Here is our prompt. Imagine an electrician working on a switchboard with exposed wires in a newly built office space. This is always good to specify the photorealistic style that we are after. Again, a set of 4 images are generated, and we can use the best one and animate it. The animation clearly shows some leading indicators, like wearing no face shields, gloves, or eye protection. This can be tracked by object tracking algorithms like FastRCNN to assess PPE compliance and hand movement near live wires. These are leading indicators to electrical shock or injury from sparks. Our next video analysis scenario is focused on painting safety risks. This is the prompt we provided to Meta AI. Imagine a painter spraying a wall inside a confined space without ventilation. The image is generated with a latency of less than a second, and we can animate it to train our deep learning action recognition and tracking algorithms. The animation shows that the worker is not wearing a mask or goggles, which is a leading indicator to inhale paint fumes. The room has a closed window, which suggests poor air quality. Action recognition algorithms like 3D CNNs can focus on spraying, and object tracking algorithms like deep sort can assess different elements in this animation. Now let's focus on leading indicators to project incidents related to roof tiling. We provide this prompt to Meta AI for text-to-image generation. Imagine a roof tiler working close to an unguarded opening on a roof under construction. For this, we need a hyper-realistic style. The images are generated by Llama 4, and we can select one to animate it. The animation shows our worker wearing a hard hat and high visibility vest, but no harness or fall protection is visible. This can result in a significant injury by fall risk considering the height and proximity to the opening. Also, the worker is manually placing tiles, which suggests a labor-intensive process with potential for a strain or fatigue. The site also includes a ladder and scattered materials, which increase the risk of tripping or falling from heights. Modern detection algorithms such as YOLO version 12 and detection transformers or DETR by RoboFlow can analyze such animations very effectively. Also, action recognition algorithms can assess posture and movements on the roof. In our final safety analysis scenario, we focus on trench-related incidents. Our simple prompt is imagine a worker in an unsupported trench. We can select a good image and refine it with follow-up prompts. The image to animation by Meta AI looks like this. As you can see, the worker is wearing a hard hat, safety goggles, gloves, and high visibility vest. However, no shoring support is visible to stabilize the trench. The worker is using a shovel for excavation or drainage, which suggests manual labor in hazardous conditions. The muddy water and steep trench walls indicate risk of collapse or drowning. Proximity of heavy machinery can also make the trench unstable. These factors indicate a high risk of trench-related incidents because of no shoring or protective system in place. These leading indicators can be assessed by deep learning algorithms to generate early warning signals. As you can see, Meta AI's animation tool offers a cost-effective solution for creating synthetic datasets that can be used by researchers for training deep learning algorithms. This is particularly important in safety analysis contexts with limited data available on near-miss incidents and related leading indicators. This is true that Sora by OpenAI and Veo 3 by Google can produce realistic videos for filmmaking and other use cases. However, Meta AI focuses on accessible and customizable animations that are suitable for research needs, where control and scenario-specific data is often more valuable than cinematic quality. Meta AI is now using Llama 4 Maverick and Llama 4 Scout, which is their latest LLM or large language model. These models power Meta AI Chat and also WhatsApp, Instagram, and Messenger. Meta AI is now working on MovieGen, which is an AI-powered movie generator that can create high-definition videos with synchronized audio similar to what we have seen in Sora and Veo 3. Keep an eye on Metal official announcements for updates on MovieGen availability and potential release dates. Hopefully you found our review of Meta AI animation generation in this platform helpful. If yes, please give it a thumbs up and consider subscribing to our channel. We'll see you in the next one.